Now, integration in this form. So this is the general form. Sometimes we will encounter certain questions and they will be in this form, meaning there is a function at the denominator, but when you differentiate that function, it will be at the what? Numerator. And that form, we have a special way of what? Integrating it. Now let's consider, these examples. We have integral of, let's say, 2x plus 3 on, we have x squared plus 3x minus 5 dx. This is in the form of that. Are we okay? It is in this form because when you, this f prime of x means the derivative of what? F of x. And truly when you differentiate this denominator, that's the derivative of x squared plus 3x minus 5, you are going to get what? 2x plus 3, and that is the numerator. So in situations like that, how do we integrate the form? The numerator is a derivative of the denominator. Another case is this when we have case 2, integral of 3x squared on x cubed minus 1. Do we say this? Yes, the numerator is a derivative of the denominator. When you differentiate x cubed minus 1, you are going to get 3x what? Square, and that is what exactly at the numerator. What do we do? Are we good? So now we know that from simple analysis, when we were writing the special case, we saw integral of 1 on u with respect to what? The u is equal to what? Ln of u plus c. Are we okay? Anytime we have integral of this form where the derivative of the denominator is the numerator, we say the final answer is ln of that denominator. Are we okay? So 2 integral of 1 on x dx. Since the derivative of the denominator is the numerator, then the integral is ln x plus c. Are we okay? So third, let's say integral of 3x squared on x cubed minus 1. The derivative of the denominator is equal to what? The numerator, meaning the answer is ln of the denominator x cubed minus 1 plus c. Are we okay? But what if we are to show working? We cannot just write it this way. We have the idea that this is how we are going to get, but how do we prove the answer? So let's try our hands on how to go through the normal process of getting the answer. But just put it in your mind that anytime you have it in this way, that is you are going to get the ln. Wherever the derivative of the denominator is equal to the numerator, you have to get ln of the denominator. But there are special cases where you have to do certain things, and we will go through all that. So let's look at this example. Then we go. Number 1, if we have integral of 2x plus 3 on x squared plus 3x minus 2 dx. Can we see that the derivative of the denominator is the numerator? Yes. But how do we solve it step by step? So first, we will do what we call substitution again. We can say let our u be equal to the denominator, which is x squared plus 3x minus 2. Are we okay? Since we are bringing in the u, we have to take care of what? Dx. So I can say du with respect to x is going to give me 2x plus 3. So making dx the subject, I'm going to get dx equal to du on 2x plus 3. Therefore, this integral is going to be equal to integral of, I have my 2x plus 3, but let all this be u, so I still have my u. Dx is equal to that. That is du on 2x plus 3. Looking at the term, this can take care of that. So I'm going to have integral of 1 on u du. But we already know the derivative or the integral of 1 on u, which is also equal to ln of what? U plus c. But what is u? We let our u to be equal to the s squared plus 3x minus 2 plus c. So are we getting why we are getting that short answer? So anytime we have this, it is going to be ln of that, and this is the process. So let's check example 2. So 2, integral of, we have 3x squared on s cubed minus 4. So first I will pay attention and ask myself, is the derivative of the denominator equal to the numerator? Yes. So I know what I should get and how to do my substitution. So I'll let here u be equal to the denominator again, 3q on 4. My du dx is going to be 3x what? Squared. Therefore, which implies that my dx is du on 3 what? X squared. I'll bring it back to get my 3x squared on, this is u now. Dx is now du on 3x squared. Taking care of that. So I'm going to be left with 1 on u du, which 1 on u will give me ln of u plus c. In that case, I'm getting ln of the u, which is s cubed minus 4 plus c. Are we okay? It's very simple. So in objectives, you just check if it is true, then it will be ln of what? The denominator. But there are special cases where you have to pay attention. It is not going to be a direct derivative. You just have to do some substitution, some factorization, and others before you can get it in the form. Remember, you must always obey the form integral of f prime of x, f of x, before you can say that the answer is ln of what? The f of x plus c. You should always let your answer or question be in this form. Are we okay? So let's look at some special cases. So 1, what if it is this? I have 6x squared on s cubed minus 3 dx. If I have this question, is the derivative of the denominator equal to that? No, because the derivative of s cubed minus 3 is going to be what? 3x squared. And here is 6x squared. So what do? We can say that this question is the same as integral of 2 multiplying 3x what? Square on s cubed minus 3. Since this is a constant, I can bring it out, making 2 multiplying 3x squared on this whole thing, s cubed minus 3. Then we are getting it in this form, meaning now the derivative of the denominator is now equal to what? The numerator. And we already know what this is going to what? Give us. So the integral of this alone is going to be what? My 2 is there. This is going to give me ln of s cubed minus 3. Are we okay? All right, so you have to do the necessary substitution or the necessary factorization before you can get the correct answer. Let's look at the second example where it's also a special case. Now, example 2, special case, I have integral of 2x squared on s cubed minus 3 dx. The derivative of this is still 3x squared, but here is 2x squared. What do? Don't get confused. You still have to get it in that form. Are we okay? So still this is expressed as 2 multiplying x squared on s cubed minus what? 3 dx. We still don't have our 3s what? Square. What do? I have to get 3s square here before that general form will be what? Obeyed. So to do that, this is mathematics. Whatever I do to the numerator, I do that to the denominator. Can I multiply both sides by 3 on 3 such that I'll get my 2, that s cubed minus 3. This is just 1. Are we okay? It's just 1. So meaning if I multiply through, I'm going to get integral. This 3 is going in now. So I'll be left with 1 on 3 integral 2 multiplying 3x squared on s cubed minus 3. Remember, this 3 can just take away. So we've done nothing to the question. We are just modifying it in such a way that we will get our general form. And I can bring these 2 also out. So still the question is going to be 2 on 3 integral of now 3s squared on s cubed minus 3. So this is now the general form, but it is being multiplied by 2 on 3. Do you see that? So until you are able to go through the process and convert the question back to the general form, you won't be able to use that approach. So now I have 2 on 3. I know the integral of this is now, since it is the derivative of the denominator, is going to be ln of the denominator, which is s cubed minus what? 3 plus c. So this is the general answer. So the integral of that is going to give us this. Are we okay? So let's look at this. What is the integral of tan x dx? Tan x dx. Do we know? But we know that tan x is equal to what? Sine x on what? Cos x. So can I bring it back and say this is equal to sine x on cos x dx? We can see that the derivative of the denominator is equal to what? The numerator. Just that there is a negative. If you differentiate a cos x, you are going to get negative sine x, meaning we can convert this to what? The general form and use that approach. Are we okay? So I will let, which implies that let my u be equal to cos x. Du on dx is going to be negative sine what? X. And my dx will be du on negative sine x. I'll bring it back here where I'm getting sine x. My cos x is now u, then du on negative sine x. This will take care of that. And my answer or my question is now going to be negative 1 on u du. Still negative will come out 1 on u du. And I know the integral of 1 on u, which is negative ln of u plus c. And that is ln of u is what? Cos x. Cos x plus c. You can further see that negative ln of cos x is positive ln of sec x plus c. You can leave your answer this way and you are correct. So this is one form of integration. When you are given the question, pay attention, make all the necessary requirement and see if it obeys, and if not, is there any modification you can make so that it obeys the general form. Are you okay? It obeys the general form before you can solve it. So this is one special case. Thank you for watching this episode. See you next.